Then it comes back down to the structure of our cells. So without giving too much away, it doesn't look like anything I showed you, but what it means is that the cell pitch, so this is the difference between this cell and the next one above it, typically in the market somewhere between 1 and 1.4 millimeters depending on materials. In our case, we're already at 0.8 millimeters and we'll get down to 0.6. But in parallel, we're able to always make sure that the hydrogen is going to the catalyst, that the water is not getting in the way, that we're able to have effective thermal management, all these other things that come into play, which means that the amount of power we can create per centimeter squared is industry leading. So those two things combined give us.
So hi Chris, how are you doing?
Ravina, nice to see you. How are you?
I'm doing good as well. So a lot of innovation is happening around this sector. And I wanted to understand, even though there are a lot of innovations, a lot of development is happening around this domain, but there are a lot of the adoption of this technology is not as high as compared to the innovations. So if you could just give us a perspective as to why that may be so.
Yeah, so I think there's two major reasons. The first is obviously the whole hydrogen infrastructure, which is still developing, which takes time. And I think people were maybe over optimistic some 2-3 years ago, but I think the realism has set in. But nonetheless, we're seeing that real projects are getting funded. That nonetheless, the overarching sort of production, storage, hydrogen, blah, blah, is happening. On the fuel cell side, however, despite the innovation that we're seeing, the way we see it, I think that a lot of it is incremental, and that the main customer pain points of cost and complexity are still there. So that's it. So basically, using a fuel cell is still quite a complicated process for a user, and it is far too expensive. And that is something that is not fundamentally addressed by enough players in the field.
All right. So how is like EH Group able to tackle this?
So fundamentally what we have, and I'm going to show this, we're going to do a little bit of show and tell, just so that
Okay. That's great.
Here. So this is a fuel cell stack.
Okay.
This is the core of the technology. For the last 15, 20 years, it's been improving in the industry. It still, as I said, it remains too costly, complex. At the heart of it is a cell, and the inside, the microstructure of our cell is very, very different to anybody else's. So that gives us very strong performance characteristics, but most importantly, it's also designed for manufacturing, which means we can produce it at scale and even in small volumes at much lower costs. So the key to understand is that this is not like lithium-ion batteries or where materials are the majority of the cost. Here it's process. With a bit more show and tell, this is what's called like a bipolar plate. You may be familiar with this. So this is inside the fuel cell. On top of it, you typically put what's called a gas diffusion layer and a membrane, and then you reverse it the other side. So this is more than half of the cost of a fuel cell stack, even though it's all it is stainless steel with some coating on it and some channels. But to make the channels, to make the coating, to make the laser welding, because there's two of these, to do the dispensing for the sealant, these are all processes that are typically done by different partners or different machines at the very best. And so we're still in a very artisanal phase in the industry as a whole. Our microstructure doesn't look like that at all, and therefore we'll be able to produce it in a very, very different way. All in one continuous process, from raw materials to fully assembled stack in one process. So that's where we're able to be very aggressive on cost reduction.
I know. I'm just amazed to see that. I think this is the first time I'm seeing a hydrogen fuel cell right in front of me being presented that way. And my next question was going to be that you're able to produce like twice as much power density with just that. And I just wanted to get a little more about the process, or like how are you able to do this, which others are not able to do,
Yeah. So then it comes back down to the structure of our cells. So without giving too much away, it doesn't look like anything I showed you, but what it means is that the cell pitch, so this is the difference between this cell and the next one above it, typically in the market somewhere between 1 and 1.4 millimeters, depending on materials. In our case, we're already at 0.8 millimeters and we'll get down to 0.6. But in parallel, we're able to always make sure that the hydrogen is going to the catalyst, that the water is not getting in the way, that we're able to have effective thermal management, all these other things that come into play, which means that the amount of power we can create per centimeter squared is industry leading. So those two things combined give us the power density.
Okay. All right. So then, like, how does the fuel cell industry, the hydrogen fuel, compete with, like, how do you think it's going to compete with battery electric vehicles? Sorry, battery electric equipment.
So I think so. It really depends what application. So obviously, battery electric vehicles for anything that is small. So bicycles, motorcycles, cars, most trucks, I'd say, are heading the way of electric. So
Right.
this is the way it's going. So don't have to fight it there. Where we see a lot of traction is in the marine sector. So these are typically anything from tugs, support vessels, auxiliary power for cruise ships, etc. This is dictated by IMO regulations, which have just been kicked in, and the need to decarbonize the maritime sector. And frankly, on those types of applications, batteries just are really going to struggle to compete. They're just too big, too bulky, too heavy. And that's really where we're seeing sort of the first bit of strong traction in mobility, as well as in aviation. And we know that aviation is going to take a lot longer. It's going to be 10 years. It is not going to be the largest aircraft, but anything from, say, 15, 20 seaters all the way to 100, arguably 150 seaters have the potential to operate on hydrogen, while batteries are not a contender there at all.
Okay. All right. So do you feel that this is something that is right now you're targeting heavy vehicles and you're targeting like power grids, and it's like catching the big fish and then the small fish would eventually follow. Like,
No, I don't think we need to think about the small fish too much. Come on, let's have one more show and tell.
all right.
Show you our 250 kilowatt marine fuel cell system, and I'll tell you where it goes as well as marine. So basically, this is it. Inside it, we have a 300 kilowatt stack, which is right, and then it fits in this part up here. Then we have the balancer plant, and then we have a heat exchanger, and we have DC-DCs and so on, and all the connections. So if you see from the shape, it's designed to go into a container.
Right.
The same, but this has approval. It's actually primarily designed for marine. It has approval in principle from DNV for marine certification, but it's exactly the same system, pretty much, that goes into large stationary power. So where do you need large stationary power with a fuel cell? You can't use a battery. So it's either where you need much longer duration, more sort of seasonal microgrids. So you have a battery, but you also have a fuel cell. And we're seeing a lot of interest also from the data center sort of developers, including the very large ones, where they need something refuelable. So batteries are not the solution there because, inherently a data center needs something that, in theory, can be backed up forever.
Yeah. So I was just while you were telling me about and showing me, firstly, that's like seeing it in front of me, the hydrogen fuel cell that you've shown and the actual encasement of that. It's mind blowing because it's one thing to see it over the web and say, okay, fine, it's going to be like that. It would be like that, and it's another to actually see it. So thank you for that. But another thing I feel you've just mentioned, and I'll go back to what I said about adoption being a challenge, but infrastructure, the refueling of hydrogen fuel cells. So how do you feel like how is Hedge Group or how do companies, how are they going to manage that?
Yeah. So honestly, this is a big challenge for sure. So in the maritime sector, we see that there will be various fuels depending on what's being bunkered where. So at the moment in Rotterdam, major port, they have strong ambitions to put quite a bit of liquid hydrogen because they have a big liquefaction plant. But we actually see quite a lot of interest also from in methanol. So for us, that methanol needs to be reformed and then it comes into our fuel cell. But methanol is actually quite a good carrier in terms of safety and in terms of energy density.
Right.
There's also ammonia, which comes into that picture, which has a lot of proponents because obviously it has no carbon molecule attached to it, but comes with some more sort of safety considerations.
Yeah. I mean, hydrogen itself, if it leaks, it's just going to be destructive. And like you said, that, carrying it, like using methanol, is one of the ways of converting that energy into hydrogen. So I just wanted to know a little more about how are you managing like the thermal management of the hydrogen fuel cells, because that is something, it's a challenge, and especially if you're using it for maritime where it's going to be used for a long period of time. So how are you able to, or how's the technology able to tackle that?
Yeah, honestly, that isn't such a big challenge, especially in maritime. You have plenty of water just nearby,
Mhm.
and you can just use a heat exchanger. So honestly, that isn't the biggest challenge we have. I think the storage of the hydrogen and or methanol is a bigger challenge, and the overall infrastructure there is the thing. But just as a reminder, in the U.S. alone, there's something like 25,000 fuel cell forklifts that
Mhm.
run around for Walmart, Amazon, etc.
Mhm.
So it's very safe. They refuel. It takes them basically 3 minutes to refuel, and they do
Mhm.
basically 8-hour shifts, no problem. So yes, of course, it leaks and it can leak, but the whole point is you got to have the right things in place so it doesn't.
Cost being one of the factors which you've mentioned that has been able to successfully bring down. How were you able to do that? That is a current challenge that not many companies are able to achieve that, but you are able to do that. So if you could give us some insights into
Yeah,
that.
sure. So there's two sides of it. So one is at the stack level, which I kind of referred to, that we've eliminated all these processes, in making the stack and
Mhm.
combined it into one continuous process. So we've simplified the production and assembly, which leads to big cost reduction. The other side is at the system level. So the box you saw outside,
Yes.
typically for a 250 kilowatt system on the market from say one of the leading other fuel cell manufacturers, you would have two or more fuel cell stacks, and that means
Yes.
you would have a much more complicated balance of plant. That means you have
Mhm.
multiple compressors, multiple etc. In our case, we have one stack and we are able to have therefore one balance of plant. So one single compressor, one hydrogen loop, etc. So there's far fewer components in there. There's less complexity, a simplified architecture. So that too brings down the costs.
Okay. All right. And just I had this question in my mind that I wanted to ask. You mentioned that in the US, the hydrogen refueling is not much of a challenge, but as it plans to grow, how do you think that refueling of hydrogen is going to be tackled in other regions, and how just to grow, what are the challenges you feel that is it going to be a challenge, something that you see is going to be covered up in time as this technology is being adopted?
Yeah. Sure. So just to clarify, I was referring to just the forklift market in the US.
Right, right.
These are refueling stations within the forklift. I'm not talking about for trucking and so on. So obviously for heavy duty mobility, it's much more problematic just because of where do you put them, etc. What we're seeing in Europe is some traction with the 350 bar refueling stations. Where I think though you have to look is what's happening in China. So this is a familiar pattern where the US goes hot and cold on climate tech. Europe tries to burst ahead but has a handbrake in terms of regulation. And meanwhile, in China, they are pushing ahead. And I know India has also very strong ambitions in the hydrogen sector. We can talk about that after. But in China, this has obviously become something of a strategic initiative, even though it's somewhat under the radar and the focus has been on battery electric vehicles and etc. But we see some strong players emerging, and we see a fair bit happening on the heavy duty trucking, more the long distance stuff. I mean, electric trucks too, but certainly an infrastructure is starting to emerge in certain areas of China with that.
Mhm.
And yet again, I think they're quite ahead of the curve on that front.
Okay. All right. So, Chris, this is a question that I wanted to ask, which is more on a personal level, and it's like you've co-founded this company, you've had a background in finance, and you've shifted to a hydrogen fuel cell, which is like jumping an ocean and saying, okay, fine, I'm going to start with something this. So, I wanted to know what challenges did you face? Like, did you ever feel like this is like completely different from what I've been doing for so many years? And at some point, did you feel like, it's not going to work out, or it's something that, oh, I shouldn't have done it? Anything that you felt, and like, how were you able to muster through during those times?
Yes, we get those times often. So basically, my background is basically I ran a sort of macro hedge fund for 20 years, and I seeded this company with my co-founder, who he has a very strong background on the technical side, hydrogen sector and fuel cells for over 20 years. And of course, as you said, it really was jumping into a very, very deep end, and I'm not sure I've touched the bottom yet. So, I mean, at the end of the day, though, I'm sort of when you're building a business is about creating structure and finding opportunities and thinking about narrative and go to market and organizing and so on. But I will honestly say it's much harder than what I used to do. Really, running a hedge fund was much easier.
Much easier.
So, and then where do we find the inspiration? You know, we have an amazing team here. We're 25 of us between here and actually we in Switzerland, but we also have facilities in IIT Madras Research Park. And we're very mission driven in terms of, I think other people could probably get, you know, better paying jobs that with less technical challenges and the rest of it. But we are trying to make a difference and an impact, and that motivates us during the difficult times.
But any like personal, like you felt like, yeah, I didn't know I had it in me to do this. I did it. I accomplished this challenge because, like you said, hedge fund completely different. This you're like, it's gonna be something that you're in and day out. And how did you, on a personal level, if you faced a challenge like it's not really working out, it's not really. So how are you able to
Yeah,
get through?
you just can't think like that when it's when the tough times are there, and there are plenty, believe me. All sorts of things, all sorts of unknowns that, you know, risks that you really didn't think were risks in the first place. You know, at the end of the day, we have a very strong belief in terms of what we can offer in the market. We know it takes a long time, and this adoption in the hydrogen sector is taking longer than people expect. But we have some traction with some very big players in aviation, in maritime, in data centers. So this gives us confidence that, you know, we do in oil and gas as well. So we do have confidence. This gives us confidence that fundamentally we have something different that can really sort of help transform, you know, certain aspects of our economy on the energy production side. So you just got to persevere. If it was easy, someone else would be doing it.
It's like they say that when the going gets tough, the tough gets going.
Yeah. So Monday mornings, we typically get a few punches in the head to start the week off. But it's okay. It's all part of it. It's all part of it.
It's all part of it. But all right, Chris, that's all from my end. And I try to stop the recording right now.
Sure.